In lesson 3-5, we're going to be talking about the Pythagorean Theorem. Pythagoras was a mathematician a long time ago, and he noticed some similarities when dealing with right triangles. And those similarities are going to help us today to figure out the distance on one of the legs, or actually it's called the hypotenuse of the right triangle. Um, what we refer to as legs are A and B in the diagram here. This is a leg of the right triangle. The legs of the right triangle are what come together to make the 90-degree corner. And so the hypotenuse is always directly opposite the 90-degree corner. C is always labeled as the hypotenuse. A and B, it really doesn't matter which one is which, but A and B are always used as letters to represent the legs of the right triangle, and C is always used to represent the hypotenuse of the right triangle. So Pythagorean theorem, that's the theorem we're going to be working with today. A converse means that if something if something follows a certain set of rules, then that means conversely that it must be true or must be false. So let's get into our Pythagorean theorem. And the Pythagorean theorem is c squared equals a squared plus b squared, or you can say a squared plus b squared equals c squared, which is most commonly said by mathematicians all over the place. So usually in this order is how you hear it: a squared plus b squared equals c squared, where a is the length of one of your legs. So a, we're going to take that number and square it, plus the square of your other leg, and then the sum of those two squares is going to equal the square of the hypotenuse, which is always c. So we can use these relationships to help find the missing leg or hypotenuse of a right triangle. So it says write an equation to find the length of the missing side of the right triangle. Then find the missing length. Round to the nearest tenth if necessary. Because we're taking the square root of numbers, we may not always end up with perfect squares. So we're going to have a squared plus b squared equals c squared. I would expect you to show this in your homework when you're starting out, because it says write an equation. So this is our equation right here. It doesn't matter which number you choose for a and b, just go ahead and plug them in. So we're going to do 12 squared plus 16 squared, and that equals our hypotenuse squared. 12 squared is 144, okay, plus 16 squared. If you know what that one is, you can go ahead and just write it down. Otherwise, you can always refer to your calculator to help you out. It would be good to memorize and get to know your perfect squares, maybe up to 15, 16, 17, 18, even get to 20 would be great. So again, we're talking about 16 squared, which is 256. And that again is still equal to our hypotenuse squared. So we'll keep moving down here. We have 144 plus 256. If you want, you can write it below here to help you add it up. And we get a 0, 1, and that'll make another 10, 1, and then we have a 400. So right now we have 400 equals the square of our hypotenuse, or c squared. Now again, we're going to take the square root of c squared, and whatever you do to one side, do to the other. So the square root of c squared is just plain c, and the square root of 400 is 20. Now you want to kind of think, we know that 20 squared is 400, but also negative 20 is also 400. But in this problem, it doesn't really make sense for us to say negative 20 inches because we're talking about a distance. So 20 inches would be the only correct and acceptable answer. If you were to say plus or minus 20 inches, that would actually be incorrect. So what we have here is the sides are 12, 16, and 20 inches long, and that makes a right triangle. because all the numbers fit into the Pythagorean theorem. For example 2, it says the hypotenuse of a right triangle is 33 centimeters long. So if you needed to, you could always draw yourself a right triangle. And remember that whenever we're talking about the Pythagorean theorem, we're always talking about right triangles. It's never any other kind of triangle. So the hypotenuse is 33 centimeters. So we know that that represents C in our equation. And it says one of its legs is 28 centimeters. So I'll just go ahead and say 28 over here. It says what is A, the length of the other leg. So it wants us to write A down here. So that means that this represents B. So I'm going to say A squared plus B squared equals C squared. And now I'll substitute for what I know. I don't know A. So A squared plus 28 squared equals 33 squared. Always keep in mind that the longest side of the right triangle is always the hypotenuse. So whether it told us that or not, please don't mix these numbers up. The hypotenuse is always the longest number of a right triangle. So going to work this out, we're going to have A squared plus, and I'll go to my calculator for 28 squared. So 28 times 28 equals 784. So we can write that in here, and that equals 33 squared, which is 33 times 33, 1,089. And we have a two-step problem here, so we need to subtract 784 from both sides of our equation. Bring down A squared. A squared equals whatever we have left here. We have a 5, 0, and a 3. So A squared right now equals 305. We take the square root of both sides, so that way we can get A by itself. So A is equal to, and we'll go ahead and go back and find our calculator, 305, and we'll take the square root of that. So it's about 17.4. About 17.4.5, so 17.5 centimeters. And we're not squaring it anymore. This is not area, even though we're solving for A. Area is usually represented with a capital A, and so lowercase a, we're just talking about the leg of one of our legs of our right triangle. So about 17.5 centimeters would be our answer there. So this is where we start talking about a converse. If the sides of a triangle have lengths A, B, and C units such that we plug them all into the Pythagorean theorem and it works, then the triangle is a right triangle. However, if I give you 3 values for A, B, and C and you plug them in and it doesn't work, then you know that it's not a right triangle and it must be some other form of a triangle. So we know that it's not a right or 90-degree triangle. So in example 3 here, we're going to kind of do that with the converse statement. So the measures of 3 sides of a triangle are 24 inches, 7 inches, and 25 inches. Determine whether the triangle is a right triangle. So again, if I just draw myself a quick sketch of a triangle, I know that 25 is supposed to be the hypotenuse because it's the longest one, and so 24 would be here and 7 would be here. It doesn't matter which one you do there. So now we want to find out if this is true. 7 squared plus 24 squared, does that in fact equal 25 squared? We're trying to see if it's true and prove to see if this is right or not. So 7 squared is 49 plus 24 squared. So we can do 24 times 24, and that equals 576. And then we want to do 25 squared, so 25 times 25 equals 625. And then we want to add these numbers together to see if they equal 625. So we'll take our 49 plus 576 and see if that equals 625. And it is true, so we can go ahead and write 625 equals 625, and we can just go ahead and circle this, and then we can say yes, right triangle. And it's okay if you just abbreviate it and use a triangle symbol. That is fine. You know, I'm not expecting complete sentence answers or anything like that. So just making sure you're letting me know, showing me all your work, that you're proving that they are true, and then you're saying, yes, it's a right triangle. And that would be sufficient. So, if this were to be some other number, if you were to get 625 over here and this is 576, then we would say no, this is not a right triangle because the Pythagorean theorem does not work with those numbers. And that's our last example for today's lesson. Be sure to check the tutors for more examples. I also posted a Pythagorean theorem rap. So feel free to take a look at that and see if it helps you remember our Pythagorean theorem. A squared plus b squared equals c squared.